Hello everyone. Today in this video we see about magnetic fields and forces. Before going to the topic, first we see about what is magnet. A magnet is a material or object that produces magnetic field. This magnetic field is invisible but is responsible for the most notable property of a magnet. Every magnet has two poles, north pole and south pole, and is therefore called a dipole. Like poles repel each other, unlike poles attract each other. The poles of a magnet always come in pairs. Magnets create a magnetic field around them. First, what is magnetic field? Here consider a bar magnet has a magnetic field around it. This field is three-dimensional in nature and often represented by lines leaving north and entering south. To define a magnetic field, you need to understand the magnitude and direction. We sometimes call the magnetic field a B field as the letter B is the symbol for a magnetic field. A magnetic field is the area around a permanent magnet or a wire carrying a current in which a force is experienced. It is called magnetic flux density. The unit of magnetic flux density is Weber per meter square or Tesla. The two unlike poles together attract. The invisible magnetic force will pull the poles together. The two like poles together repel is they will push each other apart and will not touch or attract each other at all. So the direction of the field at any point should be the direction of the force on a north pole. The direction is shown by arrows. These point away from north pole towards the south pole. The SI units of magnetic fields is Tesla. 1 Tesla equal to 1 Newton per ampere into meter. The Gauss unit is 1 Gauss equal to 10 power minus 4 Tesla. Magnetic flux. Magnetic flux can be defined as a measure of magnetic field in a certain medium. In simple terms, if the magnetic field had to pass through a certain medium, it will always travel as flux lines. Flux lines are imaginary but continuous lines traveling from north pole of a magnet to its south pole. The unit of magnetic flux is Weber. Charges moving in a wire. If a moving charge moves into a magnetic field, it will experience a magnetic force. The conditions for the force are must have a magnetic field present, charge must be moving, charge must be positive or negative, charge must be moving perpendicular to the magnetic field. How can we find out the direction of a magnetic force? So current is defined to be the direction of flow of positive charges. So your right hand rule always gives the correct direction. The thumb is the direction of velocity or current direction. The fingers is the direction of the magnetic field. The palm is the direction of the force. The magnetic field is defined from the Lorentz force law. So we know that F is equal to QE plus Q into V cross B. For a particle with a charge Q moving through a field B with a velocity V, F is equal to Q into V cross B. That is Q times the cross product of V and B. The direction of the force F acting on a charged particle moving with the velocity V through a magnetic field B is always perpendicular to V and B. To find out magnitude of the internal field. The magnetic field B is directly proportional to the current and inversely proportional to the circumference 2 pi r. That is B proportional I by 2 pi r. So the constant of proportionality mu 0 equal to 4 pi into 10 power minus 7. So B, the internal magnetic field is equal to mu 0 I by 2 pi r. So thank you.